Okay, so make sure you're familiar with your vocabulary. You know I keep the running list. Here it is. This is all for today that we're going to be going over. So we're going over one section. You do have a quiz on this section alone on Friday. You need to make sure you know the definitions to your vocabulary terms. There are 9 given by the textbook, but I'm covering a little bit more. Understand the importance of each water property. So you have 3 water properties that the textbook gives you, but there are more than that. So you need to make sure that you understand what is cohesion, what is adhesion, what does it mean that it's the universal solvent, what does it mean that it's a heat moderator, and why is that important for life. And lastly, understand the difference between an acid and a base. That's what we're going to cover today. First thing, on your notes, you have what is called a polar molecule. It all starts with the fact that water is polar. What does that mean? So a polar molecule forms because there is uneven sharing of electrons. So what does that mean? Chemically, oxygen is high electronegativity. Due to where it is on the periodic table, we know that it is a high electronegative atom. What does that mean? That means that it loves electrons.
Should we also write this in book?
You should have this already. I just add. You just want to add to your notes. You should have this already. It's from the other day. Okay. So what does that mean? Uneven sharing of electrons. Oxygen, again, it loves electrons. It's high electronegative. So what charge do electrons have? Electrons have negative charge. They're what floats around the atom. So that's what makes oxygen negative. Now, also in the water molecule, there are 2 hydrogens. That is where oxygen is pulling those electrons from. So since they're pulling the electrons from hydrogen, it makes the hydrogens slightly positive. Why hydrogen is positive. Now, because it is polar and it has those negative and positive charges, it makes it very reactive. It likes to attach to things. And so because of that, water is going to dissolve things easily. It's going to grab onto salt, break it apart, and dissolve it in water. So that's why it does mix and react with things quite easily. Items that are non-polar have no charge. So these are very stable elements and they're not going to dissolve in water. They're what we call hydrophobic. So they're not charged, they are not going to dissolve in water because they're usually made up of a whole bunch of carbons and hydrogens. That's why they're not polar. They're very stable molecules. Now because of this polarity, the charges, water bonds a certain way. It forms what is called a hydrogen bond. Hydrogen bond is formed between the hydrogen of one water molecule and the oxygen of another water molecule. So here we have a hydrogen and it's forming a hydrogen bond with the oxygen of another water molecule. Same here. This oxygen is forming a hydrogen bond with this hydrogen. Okay, this is a hydrogen bond. It's actually fairly weak, but when there's a lot of them, it has some strength. Hydrogen bond is the reason why water has those unique properties that you have listed below. High specific heat, cohesion, adhesion. Polar, covalent, and hydrogen bonds. These are the 2 different types of bonds you need to make sure you're familiar with. We just talked about the hydrogen bond. It's the bond between the hydrogen of one water molecule and the oxygen of another. Polar covalent bonds are within the water molecule. So it's the bond within the H2O molecule. It is what holds the water molecule together. It is actually a very strong bond. So polar covalent bond is the name for the bond within the water molecule. Hydrogen bond is the name of the bond that connects two different water molecules. Make sure you know that difference.
In the polar covalent bonds of this water molecule, the electrons are more strongly attracted to the nucleus of the oxygen atom than to the nuclei of the hydrogen atoms. The oxygen side carries a slightly negative charge, and the hydrogen side carries a slightly positive charge.
So again, the polar covalent bond is right here holding it together. And we have that negative cloud on the oxygen, and we have the positive clouds on the hydrogen. That's polar covalent. Now let's learn about hydrogen.
Some polar molecules have unusually strong intermolecular attractions called hydrogen bonding. These attractions occur in molecules where hydrogen is bonded to fluorine, oxygen, or nitrogen. The interaction occurs between the hydrogen of one molecule and an unshared electron pair on the more electronegative element in another molecule. The orientation of hydrogen fluoride and water molecules in the liquid states of these substances is determined by hydrogen bonding. The hydrogen atom in hydrogen fluoride is attracted to the fluorine atom on another hydrogen fluoride molecule. Water, with two hydrogen atoms and two unshared pairs of electrons.
Okay, so I want you to make note. It can form up to 4 hydrogen bonds. See how this oxygen is connected to the water of another water molecule, and etc. Okay?
Can form 4 hydrogen bonds per molecule. In ice, hydrogen bonding leads to a tetrahedral arrangement of water molecules around one another.
That is really important. The fact that when it is a solid, it actually creates those spacing due to, and that is called the crystalline lattice structure. And it has that spacing because of the orientation of the water molecule. It makes it gap that way. This allows for air to come in there, and so it actually, when it's a solid, you would think if it's a solid, it should be packed, flat, no spaces. But since water has those air gaps, it actually spreads out as it becomes a solid, and it becomes lighter, which is less dense. So water is unique. It's one of the few, and it's one of the only molecules that becomes less dense as a solid, which allows that your lakes during winters don't freeze through, and it allows for that marine life and the aquatic life in those areas to survive through the winter. So it's very important that ice is able to float.
In liquid water, the tetrahedral arrangement is not fixed because the molecules are able to move around, and on average, a water molecule is surrounded by 3.4 other water molecules.
Alright, so we're going to go ahead and model.
Here, I was 3:30.
Alright, so you guys did all of this. You found your covalence. You did a hydrogen bond with your partner. Excellent. We're moving on. Next one. Alright. Water is the only substance that can be liquid, solid, and gas. It can exist in all 3 forms. But why is this important for life? That's where you always have to remember. You have to remember, why is this important for life? Well, remember that the earth and the human body are about 75-ish% liquid. So that's very important to us. Solid, it keeps the polar regions cool and helps moderate global temperatures. That's the ice glaciers. And the gas form, it's what drives the water cycle, which we definitely need that to occur. Next, in that box in the middle, that's where we are. High specific heat. Why is it important? You might need to add that to your notes. So high specific heat is the idea that it takes a lot of energy to absorb. Water takes a lot of energy to change its temperature. So it's a heat sink. It's able to store large amounts of heat, of energy, okay, before it changes temperature. We want to think about at the beach. So we have the water and the sand. The sun is out. It's daytime. What's hotter, the water or the sand?
Sand.
Sand is hot, right? Now it's nighttime. What's hotter? Anybody been to the beach at night? What's hotter?
Water, right?
The water. So the water's not going to be hot, but it's definitely warmer. So the reason for that, think about it. As soon as the sun goes down, that sand is cooling off. Immediately cools down because it has a low specific heat. It changes temperature very fast. However, water, because it has a high specific heat, it takes a longer time to change temperature. All right? So why is this important? Two reasons. The oceans will not drastically change in temperature just because the weather is different. And so that's going to help moderate global temperatures as well as allow marine life to survive. How does it affect our climate? So when you live near the ocean, let's think about, I don't like to use us as an example because we are also south, we're in the tropics. So let's use LA, because if you look on a map, LA and Chicago or Ohio are at the same latitude, which tells you they get the same amount of sunlight. However, the temperatures are very different. So LA kind of is similar to us when it comes to climate. So anybody can take a guess, like in the winters, what it is in LA? Like a little lower. Yeah, like 60s to 70s, around 65 in LA. Now remember, LA is right by the ocean. What about the summers? How are summers in LA?
90.
Yeah, like 85, 90, never gets too hot there either. It's like awesome. Anybody been to Ohio or somewhere in the Great Plains? How is their winter? Cold. Okay? Even colder. Yep. Their summers. You ever hear about those Chicago heat waves and how people die because they have no AC up there?
What? They don't have AC?
It's just not common to have AC in their buildings and things like that. Anywhere up north, it's not common to have AC. It's a luxury. Or in Florida, you don't live without it. All right, so that is a big difference. When you live by the ocean, again, it's a heat sink. So it's going to give off that heat when it's colder outside. So it's going to keep you a little warmer in the winter. However, when it's hot outside, it's going to take in that heat. So it's going to keep you a little cooler in the summer. However, if you're not by the ocean, you are going to reflect the seasonal change, and you're going to have a drastic change in temperature. So having a high specific heat allows water to be a temperature moderator. It's going to help prevent oceans from changing temperatures drastically, and it's going to help prevent climates from changing drastically. And it's going to help people who live by the oceans to have better weather. Okay? Next, cohesion. Cohesion, I want you to remember that picture right here is water sticking to water. Cohesion, water sticking to water. It leads to forming what is called surface tension. Surface tension is the ability of water to form a film on its surface. Insects have the ability to walk on water and survive in their ecosystems because of this feature. You can think of skipping rocks. The only way you're able to skip a rock is one, it's smooth, two, it's not too heavy. So it's just enough to not break the surface tension. What is causing the surface tension? What's holding water together? Yeah, what about the water molecules? What do they have that's holding it together? The hydrogen bonds. Very good. The hydrogen bonds. Remember, all of these water properties are because of the hydrogen bonds. Water